Now let me input I'll input the data into R and we'll run the code. So we have treatment. So the number of treatments should be, use the post, subtract the pre. Right. We can see those are the treatment and control. Control. So we have 10 numbers in treatment, we have 8 numbers in control. Okay, so then we can run those code. Let's see. Let's run the code for likelihood first. Okay, so yeah, this is a likelihood function, and you see if you make mu1 is 10, sigma1 is 3, mu2 is 10, sigma2 is 3, then the likelihood equals to this number. Or you can change them, then you can check those likelihood. And then let's do prior. Okay, so we can try like for prior, if you make like a 0, -1, 0, 2. Oh, I need to make them into a vector. Okay, so you got 0 prior because sigma1 I put as -1, right? If it's a negative number, then the probability is always 0. Okay, then Okay, the post is easy because it's just one row. Okay, now we can run the metropolis. Okay, well done. Right, it's 10,000 steps and it's pretty fast. And you can see, starting point is 10, 10, 10, 10, and when we run it, let's see, it will converge. Right, we'll run it. Gradually, you can see that mu1 is still at 11, 12, but sigma 1 decreased to 2, and mu2 decreased to 6 or 7, and sigma 2 becomes 2 or 3, right? See, it's far away from 10 now. And yeah, so you can see this is the Markov chain value, and we're not going to eyeballing them, we're going to plot figures and to check. Let's see. Take those out, and then I can plot. Let's see, mu1. This is a figure for the mu1. So, okay, for mu1, I think it looks like we starting from 10. It's not far away from the density, right? It's from the beginning to the end. It looks like it's quite stable, right? There's not very obvious change in this case. Well, let's check. Yeah, let's check mu2. Yes, there's a more obvious. For mu2, you can see at beginning it's 10, but then it's actually changed quite a bit, and then reverse, and then stable around something like 7, right? It's clearly not centered at 10. So there are unstable stages, like this part, we call it the burn-in, and this part, the Markov chain does not converge to the limiting distribution. So we cannot take those burn-in part as our final sample. So in our case, let's say if I take 1,000 step as burn-in, the first 1,000 step, we have to discard those part and only keep the following part as for our samples. The more obvious one, I think, is use sigma. Let's see, look at sigma 1. See, that's much more clear, the burn-in part, because you can see that clearly the density for sigma 1 is far away from 10. It's much smaller, right? It's actually around between 2 or 4. And if you give original value is 10, it's actually much more like it will decrease, randomly but gradually decrease until it becomes stable. So it does not mean that the sigma 1 cannot be 10, but the chance for sigma 1 equal to 10 actually is very, very small, right? So the most probability density actually around between 2 or 4. So again, we can take like 1,000 step as burn-in part, and we can discard the first 1,000 steps and take the following part as stable. We can check sigma 2. Okay, see, the same thing, right? The same thing here. So you see, after the Markov chain becomes stable, converts to the limiting distribution, the most density around 2 or 4. Although the beginning part, when sigma 2 is starting from 10, it's actually increased a little bit, but then it realized that that's not the correct way to go and it's decreased. So the whole process is actually random, but gradually this mark option will converge to where that we will make the values that will make the posterior bigger, right? If you go up, then the posterior actually will become smaller, so that's why it's gradually randomly actually gradually decrease to here. So again, we can take 1,000 step as the burn-in part, burn-in, right? Yeah, we take a burn-in equal to 1,000 steps, and then discuss the first burn-in part and take the following part. Well, although occasionally, you know, the value can still go up to 10, like this, but the probability is very small, right? So this doesn't mean that the mark option does not converge, because you can see it's recursively occasionally can go up to 10, but the chance should be very small, right? The probability should be small. So it's only the first part, those parts actually are burn-in, that we will not count them in our samples.